You know how your weather app just knows the forecast? Or how you can book a flight using info from a dozen different airlines, all in one spot? Well, the secret sauce behind all of that is something called web services. They're kind of like the invisible engine that lets all our favorite apps and systems talk to each other. So let's dive in and see how this whole thing works. So, here's what we're going to cover in this explainer. First, we'll break down what web services actually are. Then, we'll get into why they're so incredibly important. We'll also look at a couple of common challenges you might run into, touch on how to keep your data safe, and finally, see how they fit in with their modern cousins, APIs, and microservices.
All right, first up, what in the world is a web service? Let's get right to the heart of what these so-called digital translators are actually doing behind the scenes.
I mean, think about it for a second. You've got your phone, your laptop, some company's giant server. They could all be running completely different operating systems, written in totally different programming languages. How on earth do they manage to have a conversation?
And that's exactly where web services come into play. They're basically the communication bridge. They create a standard common language so that a client, say your app, can ask for something, and a server can understand that request, go find the info, and send a response back. It all happens right over the internet.
Okay, to make this super clear, let's use an analogy. Picture this. You're in a coffee shop in Paris, but you don't speak a word of French. You're the client. You turn to your friend and ask for a coffee in English. Your friend, who is bilingual, acts as the web service. They turn around, order the coffee for you in perfect French, get it from the barista, and bring it back to you. See? Your friend made it possible for two systems, you and the barista, to communicate, even though you couldn't understand each other directly.
Now, these digital translators really come in two main flavors. First, there's SOAP. It's a bit more formal, kind of strict. It sends messages in a very structured format called XML. Then you've got REST. REST is much more flexible, and it uses the same web protocols your internet browser uses every single day, like HTTP, to get stuff done.
Okay, so we get what they are, but why should we care? Well, it turns out web services have some key advantages that are basically superpowers for anyone building software. First up is reusability. Why would you build a whole payment system from scratch when you can just plug into a pre-built one? It saves a massive amount of time. Second, interoperability. A service written in Java can have a perfectly normal conversation with an app written in Python, no problem. Then you have usability, which makes data accessible everywhere, and deployability. Because they use standard internet tech, they're available literally anywhere in the world.
Of course, it's not always a completely smooth ride. When you've got all these different systems talking to each other across a network, there are a couple of pretty common potholes you really need to watch out for.
The first one is called latency. And really, all this is the delay between when you ask for something and when you actually get a response. It's that spinning wheel of doom we all know and hate. That agonizing wait, yeah, that's latency.
You've definitely felt this. You go to a travel website, you click search for flights, and the little wheel just spins and spins and keeps spinning. That right there, that's high latency. It makes for a terrible user experience, and it's a huge headache for anyone building an app that depends on web services.
The second big pothole is something called partial failure. This is what happens when a process needs to talk to multiple web services, but just one of them messes up or doesn't respond. All of a sudden, the entire chain can just break.
Think about buying something online. You search for a book. That works great. You add it to your cart. No problem. But then you click buy and the payment service fails and you get a big red error message. The search service did its job, the cart service did its job, but the failure of that one little purchase service broke the whole process. Now, a well-designed system will handle this gracefully and maybe keep the book in your cart so you can try again later.
So with all this information flying back and forth, security is obviously a huge deal. How do web services act as a kind of digital bodyguard for our private information?
Well, the basic idea is something you use every single day. To use your phone, you need a key, right? Your passcode, your face, your fingerprint. Web services work pretty much the same way. An app needs to show the right key or token to prove it's actually allowed to get to the data.
This really breaks down into two key steps. The first is authentication. This is the part that answers the question, who are you? It's you typing in your username and password. But once you're in, the next step is authorization. This part answers the question, okay, we know who you are, now what are you allowed to do? Can you only view the data, or are you allowed to change it too? And there are a few common ways to handle this. The most straightforward is called basic authentication, which is exactly what it sounds like, just a username and a password. Another really common method is using an API key. This is just a unique, secret code that has to be sent along with every single request to prove it's the real deal.
All right, for our last section, let's put web services into context with the modern family. You hear the terms API and microservices thrown around all the time. So how do they all fit together?
Here's the relationship in a nutshell, and I love this analogy. All web services are APIs, but not all APIs are web services. It's just like saying all German Shepherds are dogs, but not all dogs are German Shepherds. A web service is just one specific kind of API.
And we can take that analogy a little further. Think of an older SOAP-based web service as, let's call it the Fat German Shepherd. It's powerful for sure, but it has a lot of overhead and carries a bunch of extra baggage. A modern REST API, on the other hand, is like the Skinny German Shepherd. It's lightweight, streamlined, much more nimble, which makes it way better for things like mobile apps that don't have a lot of bandwidth to spare.
So, where do microservices fit into our dog park? Well, if a web service is one dog, you can think of microservices as a whole team of tiny, specialized dogs working together. Each one is its own self-contained little component with one very specific job, and they all communicate with each other to get a bigger task done.
At the end of the day, web services, APIs, and microservices are all just different ways for our apps to communicate. They're different languages for different jobs. And that leaves us with one final thought. We know our apps are talking to each other all day, every day. But are they always speaking the best, most efficient language for the task at hand?